Hello and welcome back to Maths with Matthew. This is going to be episode 2, EP2, down at the bottom there. This episode is going to be all about normal geometry, as opposed to last episode was coordinate geometry. This one's normal geometry. You know, triangles and circles and squares, all that jazz. But we're going to get into the questions soon. You know, have a go at them before I walk you through them. Have fun. Okay, on to the questions. Okay, so we're going to start off with this question here about this shape. So, it says a pentagon is made up from a square and an isosceles triangle. Okay, there it is there, and we need to work out the perimeter of the pentagon. Right, so what I like to do when I'm faced with a geometry question, I like to draw out the shape. Mind the bad drawing, it's because I'm on I'm on a tablet and I'm not very used to it. But I should get better over time. Oh my gosh. Right, there we go. Here's our shape here, and I've just split the shapes in half, so it's easier for me to realise that this is a square and that this is a triangle. Okay, so this full angle here is going to be 125 degrees. 125, that full angle. But we know because this is a square that all the angles here are going to be 90-degree angles, and you do that by doing like a little small square. That's how you denote that. So 90 degrees, and then this is going to be what's left over, because remember this whole angle was 125. So that means that we can say that that x is equal to 125 minus 90, which equals 35 degrees. Okay, so I'm going to write it over on that side, this side here. 35 degrees, right? And I've just removed the word triangle there because I realised it would get in my way. So, back to what we were doing. So this is 35 degrees, and then, because this is isosceles, it's going to be 35 degrees on this side too. So we know that both of those are 35 degrees. So if I split this down the middle, okay, it doesn't look it because my drawing's awful, but these triangles are going to be exactly the same. Okay, and we can see here, let's put a little right angle here to show that this is a right angle triangle now, and that's very important because we're going to use trigonometry to work out the length of this side, h, hypotenuse, this hypotenuse here. Okay, so all the square, this is square, right, square, square, so all the side lengths are going to be the same because that's what a square is. So all of those are going to be 12, and that means once we split that in half, that this is going to be 6. So it's going to have 2 6s there. And now we just need to work out this h. So we're going to use trigonometry, and the way I remember like how trigonometry works, I just, you know, remember SOHCAHTOA. And I write it out in this specific way because these are actually formula triangles. And the way you use formula triangles is basically these are divided and these are times together. You've probably used them before in like physics or whatever. So say if I wanted to know the tan, what I would do is I would ignore the tan and go, well, that's opposite divided by adjacent. In this case, we've got the adjacent and we have an angle and we're trying to work out the hypotenuse, right? So we look for the one with adjacent and hypotenuse, which is cos. So what we're going to do is, because we want to know what the hypotenuse is, we're going to ignore that for a second, and then we realize that to work that out, hypotenuse is equal to the adjacent over cos, the adjacent over cos 35. Okay, and in this case the adjacent is 6, so 6 over cos 35, and that equals, you would use a calculator for this at this point. This is from a calculator paper, so I'm just going to use my calculator, and that shows me that it's 7.3246 ... Okay, I would keep that number in my calculator because I'm going to use it to work out the perimeter of this pentagon. Okay, So now we know h. This is also going to be h because, as I said before, these triangles are the same. So then we just do the simple sum of 12 plus 12 plus 12 plus whatever that answer was, 3246, plus 7, 3246. I've sort of gone off the screen a little bit, but whatever. And that is going to equal, if I put this in my calculator, 50.65. And never forget your units, centimeters, because these are all in centimeters. Okay, so we've got another question here. It's about a sphere, it looks like. So it says the volume of a sphere is 4/3 pi r cubed, where r is the radius. And it says here that a container is a hemisphere of radius 30 centimeters. Okay, so the radius is 30. The sand fills a container at a rate of 4,000 centimeters cubed per minute. Does it take less than a quarter of an hour? I'm just going to write 15 minutes. Oh, not 15 minutes, 15 minutes next to that, just so I know I don't get confused. To fill the container, you must show you're working. Okay. So, first thing I'm going to do is work out the volume of the sphere. I feel like that would be a correct approach. There's definitely multiple ways of doing or every question that I'm doing today, probably because they're geometry based, but I'm just showing you the method that I would use. So I'm going to type this into a calculator, and that gives me this. I'll just leave it at that. That's good enough, I reckon. Okay, and that would be if this was a full sphere, right? But this is only a hemisphere, only half a sphere. So that would be as if it was a full sphere, so I'm going to have to divide that by 2. Which is that number, 7 centimeters cubed. Okay, so that's how much volume this thing can fill. 56,548-ish centimeters cubed. And now it says the sand fills the container at a rate of 4,000 per minute, and that's 15 minutes. So we're going to work out how much sand is filled in 15 minutes. So 4,000 per minute, so that means you have to do 4,000 times 15 minutes, which will give me 60,000. And as we can see, 60,000 is bigger than 56,548.7. So therefore, this is a therefore symbol. You might not have seen that yet at GCSE. Therefore, it takes less than 15 minutes. I've done that again. Mins to fill. Because basically, in 15 minutes, 60,000 centimeter cubed of sand has been poured into that, which is greater than the volume. So therefore, it is filled in 15 minutes. And there we go. Another one down. Okay, here's another question, this time about a circle. So, I don't like these geometry questions because it involves a lot of reading, which are not my strong point. But I do like the big pictures. A, B, and C are 3 points on a circle. Lovely. There they are. The radii from A, B, and C are shown. So, the fact that it says radii is important because that means that all these are coming from the center of the circle. All these lines are from the center of the circle. And the question is AC a diameter of the circle? You must show you're working. Okay, first of all, let's think of the wind conditions. Okay, basically, when is AC? a diameter. The good thing is that they're both coming from the center, which means that it does go through the center. But it also means that this needs to be a straight line. AC needs to be a straight line. And the only way that would be a straight line is if 5x plus 40, this angle here, is equal to 180. Okay? So we need 5x plus 40, I'm just going to write that over here, equal to 180. Okay. Let's actually work out what x is, and then we'll decide if this is true. So the way we would do that is by creating an equation. And this is an important skill for GCSE maths. Because I think they like to throw this in a lot. And it's not particularly hard once you know what you're doing. You just need to know like facts about the thing you're doing. And it's very useful as well to know. So basically all I've done here is I've said that, well, because this is a circle, the entire thing, all these angles combined, is going to be 360 degrees. So I've just taken that, added that, and added that, and that's going to equal 360. And now we're just going to simplify this and work out what x is. So I'm going to simplify this further by expanding the brackets here. So I get 4x plus 40 plus x is equal to 360. Now I'm going to collect like terms. 10x plus 80 equals 360. And then 10x equals 2800. That's not right. I mean 280, not 2800. That would be that. And then x divided by 10 is 28. So let's come back to this now. We know now that x is 28. We need to plug x into here and see if it's equal to 180. So 5 times 28 plus 40. And if you plug that into your calculator, or you just do it in your head, that does in fact equal 180. Therefore, is that symbol again? AC is a diameter. Diameter. Oh, spell it wrong. Diameter. There we go. Okay, so last one for this topic, and it's a fairly odd looking one. Right angle triangle ABC is a cross section of a prism. Okay. AB is 5, yeah, BC is 12, it's basically just telling us what's on the diagram. M, right, this is important, M is the midpoint of FC. So that's like, it's like a half, and that's like a half of the line, okay? And AM is 16. Okay, work out the volume of the prism. Okay, so if we look at this, right, this is actually another right angle triangle here. So if we knew this value, we could work out that value, and that's half of this, and then we could do all sorts of fun stuff with that. So to do that, work out this value, we use Pythagoras. We use Pythagoras. Okay. So a squared plus b squared equals c squared. And now we're going to work out what that c is there, right? So 5 squared plus 12 squared. I know my Pythagorean triples, so I know that that is 13 squared. Okay, so that means that AC is 13. I should have drawn a diagram here. Let me do that. So 5, 12, 13. That's that front cross section. Okay, now let's move on to this triangle here. This triangle up here. Oh dear. Ugh. Ugh. Okay. That is ACM. ACM. So we know now that AC is 13. And we know AM is 16. So we're going to use Pythagoras again, but we're going to use a sort of altered Pythagoras. Dark Pythagoras. Evil Pythagoras. No. But what we're going to do is we're going to rearrange that, is what I'm trying to say pretty much, into b squared equals c squared minus a squared. Okay, because if we look at it, we want this b here. We have c squared already. So that means b squared is equal to 13, oh no, sorry, 16. 16 squared minus 13 squared. And then we can simplify that further, so just b is the square root of 16 squared minus 13 squared. You put that in the calculator, which I'm going to do now. You get root 87. And there we go. So that is the length here. So I can't really write it on there because I've written a half there. But that's this bottom length here, cm. That line cm is root 87. And now that we've got that, we know that cm is the midpoint of cf. So that means this full line, which is what we need to do the volume of the prism, which is the... I should have wrote this at the start maybe, but the volume of prism is area of cross section so like this front bit here times length, how long it is pretty much. Now we've got root 87 here as that. The length, we know now that the length is going to equal 2 root 87. 2 root 87. Because it's going to be 2 times cm, as that's the midpoint. Okay, and now we can do the rest of this. So volume of the prism, which is what we want, is area of cross section. So if we know our formulas, that's a half base times height. And even if your exam doesn't give you your formulas, which I think they all do now, but I think it's worth learning them anyway, just because it's, you don't have to look back in the book and stuff. But that's a area of a triangle, which in this case is half of 5 times 12. The base, oh yeah, well it's the other way around really. That's the base and that's the height, but that's 12 times 5, which equals 30. And then what we want, now that we have this full area, is we want to times that area by this length to get the full volume. So 30 times our length, which is 2 root 87. And that, my dear viewers, is 60 root 87 centimeters cubed. Never forget units. It's happened to me too many times. It's very sad when you see you've lost marks, you've forgotten units. It makes me feel terrible. I'm sure it makes you feel terrible too. I've done it way more than once. But here's your daily reminder, never forget units. And there we go. That's our answer anyway. I'm just going to leave it in that form because it's just cleaner. But anyway, there we go. It's come to that time again where I'm going to have to say goodbye. I know, it's gone so quickly. And you loved it and enjoyed it so immensely. But if you want more to come back, you have to smash the like button. You got to smash that like button and the subscribe button. Anyway, I hope you enjoyed that video of Maths with Matthew. More coming soon. Have a great day. Goodbye.